This is lesson 3.2, logarithmic functions. We're going to evaluate expressions involving logarithms and sketch and analyze graphs of logarithmic functions. What you want to know is that the inverse of an exponential function, so b to the x, is called a logarithmic function. So they're inverses of each other and it has a base b. We write it log base b of x. So we're going to graph this one and this, and we're going to look and see how they compare to each other. So here are the two different functions. The red one is the log base 3 of x, and then the blue one is y equals 3 to the x. And notice they're inverses of each other. So if I draw the line y equals x, they'll be reflected across that line. So the relationship between log and exponents is that the log of base b of x equals y if and only if take the base to the exponent y, and that will give me an x. So let's evaluate these. So we need to break down 16. Well, 16 is 4 times 4, and each 4 is 2 times 2. So this is going to be 2 to the 4th. So this is log base 2 of 2 to the 4th. And if our base numbers are the same, then they're inverses and they do each other, and we're left with just the exponent. And so we can do that for all of these as well. So 1 over 125, that's 1 over 5 cubed. This is 5 to the negative 3. So this is log base 5 of 5 to the negative 3. Well, that just gives me a negative 3. 27, that's equal to 3 cubed. And if you're wondering if I'm right or not, just go ahead and break them down all the way down to 3's, or whatever the base number is. And how I know what base I'm going to is because it tells me right there. So 1 over 27 is going to give me 3 to the negative 3. So this is going to be log base 3 of 3 to the negative 3. So my answer is negative 3. Notice it's ever in the denominator. To move it up, you just change the exponent to negative. And then log of 17, well, that would be to the exponent of 1, so my answer is 1. Some basic properties of exponent is that if I take any log base of 1, it will always give me a 0, because b to the 0 is always equal to 1. So I go backwards, a base, log base b of 1 equals 0. Any log base and matches the base, it always equals 1. If your base gets repeated here, whatever the exponent is, it is. And then you can go the other way. You can make it an exponential to a log base, it should be a base b here as well, of x equals x, because they're inverses. And remember, if you multiply inverses together, they always give you an x. It's not really multiplying the inverses, it's finding the composite of the inverses. F of g of x. You know they're inverses. Remember, when you find the composite, they're equal to x. So that's what's going on here. So for this one, I need to break it down to a base of 8. And I'm picking an 8 because that's what the log base is of. So I'm going to 8 and a 64, and this is an 8 and an 8. So this is log base 8 of 8 to the 3rd. So my answer is 3. Now right here, log base 22, the base 22 to the log base of 22. Well, those are inverses of each other, so I'm left with 15.2. Next thing we look at is common logs, and that's a base 10, and that's what's going to be on the face of your calculator. So it's assumed that as long as there's not a base number right here, that it is always a base 10. So I need to evaluate this. And so this one is going to be 10, and then another 10, and then another 10 and 10. Which you could have known that because 1, 2, 3, 4. So this is equal to 4. The next one, right here, log a base of 10. So log base, there's nothing there, so it's base 10. They're inverses, so that equals 12. Now this was a log base 10 of 14. Well, 14 is not going to break down to 10. So I'm going to just put it in the face of my calculator. So your log button's over on the left-hand side. It's 4 buttons up, so log of 14 is equal to, and it's approximate, it's not an exact answer, 1.146. So depending on how many decimal places you take it to, and then log to negative 11. Well, that's not going to work. You can't take a log to a negative number, so no real solution. The next one we're going to look at is the natural logs, and those are a base e. And it's the same properties for all log functions hold true. Nothing's going to change. So we're going to evaluate it, and the ln, the natural log, and the e, they're inverses of each other, so they undo each other. So this is equal to 4.6. I'm going to go down here and do this one. It doesn't matter the order in which it comes. This one is a 4. They're inverses. They undo each other. And then the next ones we're going to put in our calculator. So the natural log of negative 1.2. Sorry. I'm going to give you an error again. It's that negative. So no real solution. And then the natural log of 7. Just put it in your calculator, please. It's equal to 1.95. We're going to sketch and analyze the graph of each function, describe its domain, range, intercepts, asymptotes, and end behavior. So I have these graphed off of Desmos. And so the domain, as you can see, there's an asymptote at x equals 0. So your domain on this is going to be 0 to positive infinity. And we're looking at the one down here, the first one. The range, well, it goes on down forever and it goes up forever. So your range is negative infinity to positive infinity. Your intercept, there's only an x-intercept, there's not a y-intercept. So the x-intercept, you can tell it's at 1, 0. So your x-intercept equals 1. You have an asymptote at x equals 0, which is the y-axis. Your end behavior, first of all, you have the limit as x goes to positive infinity, that f of x is going to positive infinity, because as we go to the right, it's going up. What about going to the left? Well, going to the left, it only goes to 0. So the limit as x goes to 0 from the positive side, or the right-hand side, because there's an end there, but that end is only going to 0. It won't go down. F of x goes to negative infinity. And then going on, increasing, well, going from the left, it's always increasing. So from 0 to positive infinity, it's not from negative infinity to positive infinity, because negative infinity would be way out here and it doesn't go there, and it's never decreasing. Well, notice I changed the base to 1/3. It's still the same thing. Actually, this is not that graph. Hold on, let me get the right one. Here we go, this looks better. This is the graph of a log with a base of 1/2, because notice the base 2, which was larger than 1, is going to be increasing, but the 1/3, which is less than 1, is going to be decreasing. So your domain on this one, again, is from 0 to positive infinity. Your range, it's going to go from negative infinity to positive infinity. Now it doesn't matter that the negative part, it's just, it was down here in the negative to positive. Your intercept, again, there's only an x-intercept because there's an asymptote at x equals 0, and your intercept is equal to 1. Your asymptote, what we were just looking at, is the y-axis, so it's x equals 0. Your end behavior, it's the limit as x goes to positive infinity. F of x is going to negative infinity. And then the limit as x goes to 0 from the positive side, only from the right-handed side, f of x is going to positive infinity. Now, this graph, it's never increasing, but it is decreasing from 0 to positive infinity. And this is what we just looked at. We looked at these properties of logarithmic functions. So if the base is larger than 1, it's going to have this growth kind of function. And anything with a base larger than 1 will look like this. Of course, you can do transformations to shift it up, down, left, or right, but it still has that general shape. And then a logarithmic decay has this decreasing type function of decay. And anything that is between 0 and 1, can't say just less than 1 because no negatives for the base. It will be this shape. And this is the last thing we're going to look at, is our transformations of these functions. So remember, if it's inside the parentheses and it's added, it's going to move it left or right, opposite of what we think. So it's a positive 1, so it's going to move it to the left 1. Next one, this has two things going on. Check out the negative and the minus sign. So it's in parentheses here with the x. So that means it's going to move it to the right 2. And the negative out front, that's a reflection. And it's not in the parentheses with it, so it's going to reflect it over the x-axis. And then C, I've got two things going on again. The negative inside the minus 3 inside the parentheses there, it's going to move it to the right 3. And then the 5 outside, it's outside, so it's a vertical. And it's going to be a vertical stretch by 5.